Tēnā koutou, tēnā koutou, tēnā koutou katoa. My name is Set Jing Xiong, but on the voting forms, I'm John Cheah. It's good and important to remember that one. Today is my privilege to present to you an overview of a project that has been very dear to me for 5 or 6 years. It was building a rammed earth house in Ahipara for my doctoral research at the University of Auckland. This presentation, oops, that's too early. This presentation is titled The Development of a Flax Fibre Reinforced, Cement Stabilized, Rammed Earth Housing Solution for Rural Māori Communities. The houses are known as whare uku, you did well to pronounce that, or uku houses. Whare being the Māori word for a house, and uku being the Māori word for a type of clay-rich soil. Before I'd start, I'd like to acknowledge my PhD supervisor, Dr. Kepa Morgan, as well as project partners Ruben Porter and Heni Hotareni, who have come down from Ahipara to support me. Ngā mihi nui, kia koutou. So first off, I'd like to introduce a little bit about me. This is part of my family in Malaysia. You can see on the couch my late grandpa, my grandma, and some of my aunties, uncles in Malaysia. I was born in Kuala Lumpur, Malaysia, and I have been here since I was 2, growing up in Auckland. So this is the finished dwelling. This is the rammed earth house that we built in Ahipara. It was finished in 2012 and has since been used for many birthday parties, business functions, and I guess as a place to meet for the extended whānau, the family. The completion of the house also resulted in the establishment of a trust, the Ahikaroa Trust, and the purpose of this trust was to protect the technology, so it was used where it was intended to be used, but also to disseminate it with other families that were interested in building whare uku or rammed earth houses on their lands. When I first went up to Ahipara, Ruben and Heni took me here. This is on their land, it's undeveloped, and they shared with me how for over 10 years that they had thought, they dreamed of living on their land, but for one reason or another, they had not been able to. It could be said they have the land, they have the access to a lot of natural resources, but they just don't have the expertise or the money to develop on their land. This situation is quite common for a lot of Māori families. And the obstacles against development are many. I'm just going to go over 3. The first is urbanization. In 1953, the New Zealand government enacted the Town and Country Planning Act, and as a result, a lot of Māori moved from their lands into urban centres. Part of the reason was to enable more farms to be established, so we could earn more money as a country. But what happened was more and more people continued to leave the rural areas, and this has led to a paucity of skilled workers, young professionals in these areas. To conduct a project like this, workers would need to be brought in. Engineering, architectural services needed to be brought in. The second issue was legal. Māori land is multiply owned, often with over 1,000 stakeholders, and getting consensual agreement with over 1,000 people is very difficult. This is also combined with the fact that Māori land is inalienable. It can never be taken away from Māori, and the banks have a problem with this, and they're not really willing to lend without a security. And so this links to the third problem, which is money. Māori on average earn less than the New Zealand average, and when you combine this with the elevated price of developing in rural areas, you've got a big problem. And for many Māori families, just getting the down payment for a mortgage is insurmountable, it's impossible. It's very difficult. On the other side, we have some needs and aspirations. If Māori are to participate as equal stakeholders in this country, as partners in the development of it, as was promised in the Treaty of Waitangi, which we as a country signed in 1840, they're going to have to live in better houses. The next thing was Māori are very strong on self-determination. They want to be able to house their own people their own way, and So a good housing method needs to give them the control, and that's represented by the Tino Rangatiratanga flag there. The third photo is a photo of Dr. Kepa Morgan's marae, Uinuku Mai Rarotonga. And I put this here to symbolize the different housing needs that Māori have. They have larger families, yes, but they also have ways of welcoming people to their site, to their home. They have protocols of placement of rooms, and they just have a different lifestyle. A good housing solution needs to take this in the design stage and to be designed for them as opposed to just given to them. So that brings me to the project question, which was, what contribution can fibre earth construction make to addressing the housing needs of Māori on Māori land? And I went about addressing this question in 3 different ways. The first way was to address end-user acceptability, and this was done from a social and cultural approach. I asked questions like, do Māori will they even use this technology? Do they like the idea of living in an earth house? The second part of the project was a theoretical validation and verification, and this was based on structural engineering theory and New Zealand building codes. And so this answered questions like, is the material strong enough? Can it withstand earthquakes? Is it durable? Will it last? The final question was about practical appropriateness, and this question asked questions like, can we build this house now? With the current level of development, can we actually build it and use it to tangibly benefit the Māori people? And while these questions are reasonably straightforward, it was difficult because we're working within a cultural context and we're working within the community. The information that we had regarding the structural performance of flex fibre reinforced rammed earth was nearly non-existent, so we had to do a lot of that from scratch. And also, as a new building method, we had to develop a lot of systems to build this house, build these panels along the way. So we developed the formwork. We had to experiment with what ways were best to mix flax and soil together, and we manufactured machinery so we could build these walls faster, safer, and quicker. Oh, faster is quicker. So to the first problem, end user acceptability. What I did was I used a decision-making framework called the Modi model. This is a framework that was recently evaluated by the Cawthron Institute alongside 10 other sustainability indicators, and this was the top of the lot. So this is a decision-making framework that's gaining a lot of traction at the moment. What I did was I adapted this framework to be used for rural Māori housing evaluation, and I went to a number of groups and asked them if they would spare some staff or some people to participate in a survey to get their responses on evaluating 2 different housing methods. There was a light timber framed house and there was a uku rammed earth housing method, and they were asked to evaluate them in terms of the 4 aspects: economic, social, cultural, and environment. Interesting thing about this model is it moves away from I guess a dollar-denominated decision-making process. It's not like a cost-benefit analysis. It evaluates things on a concept called Modi. So Modi can be described as the connection between the spiritual and physical realm. It can also be described as the life force of a living thing or object. It is an indigenous Māori concept of sustainability. Using this concept was actually quite advantageous because it allowed the stakeholders to include in the decision-making process concepts or aspects that were really important to them, but were really difficult to quantify in terms of, I guess, a monetary value, or they were not well quantified monetarily. And this was a big boon to the community, and it worked really well. As an example of Modi, if you have a polluted stream that can't support life, it's low in oxygen, that would have a negative Modi. A stream which is healthy, clean, clear, and that can support life would have a positive Modi. For a house, if a house is very costly to maintain, very difficult to maintain, it would have a negative Modi. But if it was able to be maintained by the owners, or it had long periods where it did not need to be maintained, it would have a better Modi. So that gives you an idea of how Modi can be used. Looking at this table, you can see the MODI is, it ranges from -2 to +2. -2 represents a score where it's really not sustainable. Whatever resource is being used is going to be gone soon, it's getting destroyed, the ecosystem is dying. 0 represents what a lot of sustainable development initiatives aim for, which is no more degradation. We'll keep it as is. And +2 represents an improving situation, where this is best practice, the ecosystem or the community is actually getting stronger over time. As you can see, each of the 5 groups rated the Uku system greater than the light timber frame system. And this was really positive. Particularly positive was the score of 1.6 given by the local Māori for the Uku method. And this was important because they were ultimately the end users or the recipients of this technology. This survey for this first part gave us the mandate or the confidence to go ahead with this project. The next part of the project was to do with the structural verification of the material. So on the bottom left, you can see a test panel that we built at the University of Auckland to evaluate the seismic performance and the lateral load-bearing capacity. The photo right next to it is a photo of the failed wall panel. These panels are 200 millimeters thick, 1 meter wide, 2 meters tall. They have vertical D12 steel reinforcing bars 100 millimeters in from the edge, which you can't see. And they have a cement content of 6%, a flax fiber content of 0.075% by weight of dry soil. And this is the composition that we've used for the house. The test was quite interesting, and there are 2 points I want to bring out. The first was these wall panels were a lot stronger than we expected. The first wall panel was 31% and 50% stronger in the push and pull directions. And when I say what we expected it to fail by flexural failure via the yielding of the reinforcing steel. That's what we expected, and we conservatively assumed that the earth would provide no tensile capacity. The results showed that we were wrong, and the earth actually provides quite a considerable amount of strength. What we did was we replicated this test. We did it exactly the same, and we tested it again and again. We got 33 and 35% stronger than expected in the push and pull direction. So that was one interesting result. The second interesting result was we observed the non-linear performance of these walls, and we saw actually that these wall panels had a considerable non-linear strength-bearing capacity. So we'd push them to the limit, they'd fail, and then they'd continue to bear load. And this is important from a safety perspective. After large cracks like that formed, the walls as a whole still were able to maintain about 80% of their strength, which is really good from a life safety perspective, and also has implications in design with ductility. The third aspect of the project was implementing in the community. What we did this because at the outset of this project we said this research is not valuable if we can't implement it. And so what we did was we partnered with the Ahipara community, and we worked with them through all the stages, designing it, obtaining a building consent, training up locals to build with rammed earth, and preparing materials, machinery, and ultimately being there for the build to ensure it was built to a high standard. The photo that you can see here was taken during a 5-day workshop that we held in Ahipara, where we were training up individuals from the community to build with rammed earth. It was an open invite event, so a lot of people from the community came along, and it was important that they did so, just to learn or have a look or get involved if they wanted to. In total, we probably had about 50 people coming each day, and they ranged from school children to kaumatua, or the elders. So the project was a success. We built the house. The technology has since been transferred over to a group of people that are building those houses now, and the Ahikaroa Trust, which was set up, has set a goal to build 1,000 of these houses over the next 10 years. And it's exciting because it's happening and it's achievable. We've built 4 of them so far in the area, and there's 2 more under construction as we speak, and we plan to build 5 of them this year. I'd like to finish with a bigger picture of the project. This project is actually not just about building a seismically resistant low-cost house. It's about building a strong community. And during the project, we hired predominantly young men who were on the benefit, who were in need of some guidance in their life. And over the course of this project, they gained a bit of identity and a bit of, not just skills, but some meaning and belief in themselves. And a lot of them went on to gainful employment. One joined the police academy, another one is now a flight control operator with Qantas, and a lot of them went to apprenticeships. And I think for me, although the completion of the house was something special, it was these side victories and the impact it had on individuals that made this housing project particularly significant and important. Thank you.